Welcome to Noble Hope Academy. Today we shall be looking at periodicity of physical properties, and the main one here is the atomic radius. If it is your first time to be in this channel, please subscribe, like, comment, and share our videos. What is atomic radius? First, we should know the kinds of atomic radius that we have. We have three kinds of atomic radius. One is what we call the covalent radius. Second one we have is the van der Waals radius. Van der Waals radius. And then thirdly, we have what we call metallic radius. So, what is covalent radius? Look at two atoms which are covalently bonded to each other. Two atoms of an element. If you have an element, for example, sodium. Actually, when we have a covalent, the one that can form a covalent compound, oxygen. Good. That is the O. The symbol for oxygen. And then you have two atoms which are adjacent to each other. Actually, covalently bonded to each other. The half internuclear distance of these two atoms, which are covalently bonded to each other, gives you what we call the covalent radius. So half of it from this nucleus to the other nucleus, half that distance is what we call a covalent radius. For two atoms of an element which are covalently bonded to each other. You should know that covalent bond is the one where there is sharing of electrons between two atoms within the bond. So, half internuclear distance gives you the covalent radius. Now, we look at van der Waals radius. So, this is the first one. Then the second one. In van der Waals radius, you are having two atoms which are close and adjacent to each other. Take, for example, atoms of chlorine. That is the symbol we have is Cl. If we have two atoms of chlorine and they are adjacent to each other, the half internuclear distance of these two atoms will give us what we call the van der Waals radius. Two atoms are adjacent to each other, but they are not bonded to each other. That one gives us what we call the van der Waals radius. Remember, in covalent radius, the two atoms are covalently bonded to each other. Now, how about metallic radius? Metallic radius, you take, for example, you have a metal like sodium, the symbol Na. Okay, take for example in sodium, Na, two atoms of sodium which are adjacent to each other, then half the internuclear distance gives you what we call the metallic radius. If this is an atom of sodium, and then this is another atom of sodium. Have the internuclear distance between these two adjacent atoms will give us what we call the metallic radius. So this one covers what we call atomic radius, where we have covalent radius, we have van der Waals radius, and then we have metallic radius. So in summary, for covalent radius, we have two atoms which are covalently bonded to each other. Then in van der Waals radius, we have two atoms which are adjacent to each other, but they are not bonded to each other. So half the internuclear distance gives us the atomic radius. Then in metallic radius, we have two atoms of a metal which are adjacent to each other, and half the internuclear distance gives us the atomic radius. So, as I summarize, let us look at how the atomic radius varies across a period. Take, for example, period 3 of the periodic table. Period 3 of the periodic table. How does atomic radius vary across the period? Atomic radius decreases across period 3 of the periodic table. Why? What is your reason there? So you explain why atomic radius decreases across period 3. One reason why atomic radius decreases across period 3 is that as we go across the period, there is increase in number of protons. So it means across the period, there is what we call increasing nuclear charge. We have increasing nuclear charge, and then we have same shielding effect. So the attraction between the outermost electron and the nucleus is stronger across the period, making the atomic radius to decrease across the period. The opposite happens when you're going down the group. Going down the group, take for example group 2. Going down the group, the atomic radius is going to be increasing because of increasing shielding effect down the group, and then decreasing nuclear charge. So we are going to be having the outermost electrons when they are farther from the nucleus, and so they are not strongly held to the nucleus. So to wind up, we have to know that atomic radius decreases across the period. The reason being because we have increasing nuclear charge, and then we have same shielding effect, which makes the outermost electrons to be strongly attracted towards the nucleus. Thank you for watching this video. Have a nice time.